Hi and welcome to this Leaving Cert Higher Level Financial Maths video. In this video we're going to be looking at instalment savings and pensions.
So installment savings, so sometimes interest is not as simple as our previous examples, and it's rare for people to make one deposit into savings account and just let the interest grow. So when we're using the formula f is equal to p bracket 1 plus I to the power of t, that's simply one deposit, but that is oversimplified. So instead, people make regular deposits into an account, with each deposit earning different amounts of interest because they've all been there different lengths of time. So you might have somebody who comes along and who saves every month as they're paid. So what we can use for installment savings to help us are actually the formulas we learned in sequences and series, and in particular, geometric sequences and series. So have that page 22 open in front of you as we work through these. So we're going to be focusing in on not only the sequences and series formula, but this compound interest formula. But I just said it was oversimplified. Well, if we use it once, yes. But if we use it many times, we then are able to create that geometric series that will allow us to calculate this quite complex example of installment savings. So here's the formula from page 22 that I'm going to be focusing on. It is the sum of a geometric formula. It is Sn, and we should be used to it. We have A is the first term and or is the common ratio. So let's take a look at an example. Katrina saves 400 every 3 months for 5 years at an effectively quarter rate of 0.9%. Okay. So we're going to draw this out. So here is Katrina. This is 5 years. So 3, 4. So she's doing it in quarters. So that could be year 1, 1, 2, 3. And that's year 2, 1, 2, and then ... Okay, and there's year 5. So at each of these lines, she saves €400. Okay. And she saves it here as well. And 400 and 400 and so on. Okay. So that's what the installment piece looks like. Now, unfortunately, it's not as simple as just adding those together, because if we thought about every 3 months for 5 years, so effectively that's quarterly. So we have 5 by 4, which is 20 payments. So if I said, well, actually, do I just have 400 by 20? No. And the reason I don't have that is because of interest. We are given interest any time that we save. Now, what makes this question a little bit more complex is the fact we have to figure out how long each piece is going to be invested for, because each piece is invested for a different amount. So let's simplify this picture a little bit and see what we can do. So here's a much nicer, cleaned up version of what we're looking at. We have these intervals of payment, so 400 at each interval. So this whole piece is 20 payments, so 5 years. So remember, these are quarterly, so every 3 months, which means every year there are 4 payments. And that means over 5 years there will be 20 payments overall. So if we take that first 400, that 400 is invested, and it's invested for these 20 payments. So we don't really care that it's every 3 months. All we care about is, and I'm using the formula f is equal to p bracket 1 plus I to the power of t. So I have 1 plus 0. Okay, so this is quite a small space. So 1 plus 0 point. Now, I is this, but remember we have to turn it to decimal, so it's 0 0.09. So 0.09 to the power of t, which in this case is 20. And that's our first piece. So that 400, and I'll write it down here, 400 times, cleaning that up, 1.009 to the power of 20. So that's that first piece here. So it's invested for these 20 periods of time, which are 3 months each. But then the next 400, that's only invested for 19 payments. So this one here is going to be 400 again, but it's going to be 1.009 to the power of 19, and so on. So if we want to understand how much she has saved overall, we're going to end up adding together all of these payments. So plussing. Now I haven't a huge amount of space, so I'm going to just do dot, dot, dot. And you can see my dashed lines there. You're never going to be able to draw it out in full. Now, think about these last two pieces, okay? So we're going to have to, here we have each of these boxes is effectively one period. So this 400 here is going to be 400 invested for simply one period. So, I don't know what went wrong with my pen there, 1 second. 1.009 to the power of 1. And if I calculated each of those pieces and the dot, dot, dots in the middle, and I add them all together, I'm going to end up with how much money Katrina has at the end. However, that will be long and tedious. So we need a better way to do this, and that is by using our geometric sequence. So the first question asks us to represent her savings by a geometric series, and we effectively have done this. So this is a geometric series where the first term A is actually I'm going to move this down just to get a bit of space. First term A is 400 times 1.009 to the power of 20. And we need to understand OR. So what do you multiply each time to get down to the next term? So as you can see, the power here is decreasing. So effectively what's happening is it's being divided. But we don't have division, we only talk multiplication. So it's going to be 1 over, and it's going to be that bracket, 1.009. Multiply by 1 over 1.009. Multiply by 1 over 1.009, dot, dot, dot. So that's our OR is equal to 1 over 1.009. Now, some books always start with the smallest term and work up to the biggest term. However, I find that students can get easily confused with that method. So what I tend to talk about is understanding where the bucket or the pile of money is. So for example, if you are saving, where are you going to have that lump sum of money? And the answer is over here. So at the end of the savings, you're going to have this big pot of money. And the reason I focus on where that is because then it allows us to understand, are we moving forward into the future where we can use this future value formula? Or are we working backwards? And sometimes we will have to work backwards. And if we work backwards, we're working with the present value formula. So for the moment, I will be sticking to this idea of starting where the sequence itself starts and working with the sequence as is. So the second part, so this really is part I. So the second part then says find the value of her investment at the end of the period. So what we're going to use is the SN formula. So this one here, that is a geometric, the sum of a geometric series formula to add all of these terms together. The two things you need are A and OR, sorry, three things you need are A, OR, and N. How many payments? For us, that was 20. So part 2, we're using that SN formula. So we're doing S20, and that equals A, which is 400 times 1.009 to the power of 20 times 1 minus, or, which is a fraction, so I'm going to put that in a bracket, 009 to the power of n, which is 20, all over 1 minus, or, which is 1 over 1.009. Now, that is not particularly nice looking. However, because everything here is a number, we can put this into the calculator. Just pause the video very quickly and try it yourself to put it into the calculator to make sure you're able to do it. Try to put in brackets where I've put in brackets, and make sure what you have on the camera or the calculator exactly mirrors what I have here on screen. One top tip is when you're putting in fractions, I'm going to talk you through what I'm doing. You put in the big fraction first. So this is the big fraction. So you put that line in first. So I press my fraction button and I type 400 bracket 1.009. I close my bracket and I put power of 20. I then move to the right using my arrows and I open a bracket again. 1 minus, open my bracket, 1, and then I press my fraction button, 1.009, and I move to the right and I close my bracket. So the bracket is closed around the whole fraction. I then put power of 20. Again, I move to the right to get out of the indice, and I then put a bracket at the end. Oftentimes when the errors occur, the brackets haven't been paired up properly. I now move my arrow down to work on the bottom line, and I do 1 minus 1 over 1.009, and I simply press equals, and I get 8800.89. Remember, this is money. Now, what's interesting to do is say, well, if she saved €400 and she saved it 20 times, so if you had €400 over 20 different payments, you would have simply got, oh, don't know what happened to my pen here, 1 second, you would have got 8,000. So the difference between the money you saved versus the money you end up with, that difference is interest. And we have fully calculated it properly because we've taken account of the fact that every different piece that has been invested will get a different amount of interest. So example 2, find the sum of money, P, that is needed to be saved per month to cover the cost of a €1,500 holiday in 18 months' time. The interest rate on offer is 0.4 per month. So we set up our little our little piece here. Okay. So I will always suggest that we draw this out. I'm going to try get about 3 payments, then do a ... and then do a final piece. And this all will give us this big bucket of money. And this bucket of money, we know what it's worth. That's the interesting piece about this question. We know how much we should end up with. So here we're investing P, and P again, and then that's kind of the end. So that's the end of our line and then the start of it. So we want to talk about 18 months. So this whole piece here is, oh, I've gone too far. That whole piece is 18 months. So what we have as a sequence is P, and that P is invested at 0.4%. So remember, I'm using F is equal to P, bracket 1 plus I to the power of T. It is I is equal to 0.4%, but we want that in decimal, so 0.004. So that's 1.004, and that's to the power of 18. Plus, I'm going to try line these up, so that's P. Then this one. The next piece is going to be invested, but because we put it in a month later, it's only going to be invested for 17 months. and then the next one for 16 months, and so on until our final P, this one here, is just invested for a single month. But when I add all those together, I should get 1,500. So that's going to tell me how much I need to save. If you simply said, well, look, if I want 1,500 in 18 months, divided by 18, that's about €83. But you see, the thing is, you don't actually need to save that much. You can save a little bit less because you will be getting interest on the money that you save. So if you want to be as efficient as possible, you're not going to just save and not take interest into account. You're going to work with this scenario. Now, just like the last question, we have a geometric series here. And this geometric series, we need to figure out three things. We need to figure out A, our first term. We need to figure out OR, and we need to figure out N. So again, notice that the bracket power is going down. So that means it's being divided by the power, or sorry, divided by the bracket. So our OR is 1 over 1.004. So let's set this up. A, my first term is P bracket 1.004 to the power of 18. Or our common ratio is 1 over 1.004. N, the number of payments, is going to be 18 months. And we're going to do S18. So I'm just going to clear this so we have a bit more space to work. Okay, so S18 is equal to A, which is P bracket 1.004 to the power of 18 times 1 minus, or again, I'm always going to use a bracket when it's a fraction. In these cases, it's always going to be a fraction. To the power of n, which is 18, all over 1 minus, or which is 1 over 1.004. Now, we know that this actually equals 1,500. So I'm going to get rid of that equals, and I'm just going to do a dot dot here instead. So we actually have an equation, and the reason we need an equation is because we want to solve for P. Now, that can look very intimidating in terms of, oh my god, how do I even start this? However, this section is where we learn to be really, really clever with our calculator. Because P is multiplied in, we can ignore it for a second and simply focus on this part of the formula. This part of the formula can go directly into the calculator, so you'll get P bracket, some answer, and that equals 1,500. And now it'll be much easier to do. So again, if you want to pause the video, try put that into your calculator yourself. I'm going to talk through it. So just like before, remember, if we have a big fraction, press the fraction button first. This is a complex fraction, so it is fractions within fractions. So if you don't press that fraction button early on, you're not going to be able to do it as one single fraction. On the top line, I open my bracket and write 1.004, close my bracket to the power of 18. I move out of the power, I open the bracket again. 1 minus, open my bracket, press my fraction button, 1, I move down, and I do 1.004. I move to the right to move out of my fraction. I close my bracket and I give a power of 18. I move right out of my index and I do a closed bracket. I then move down, so I'm in the bottom of my fraction, and I do 1 minus, press the fraction button again, 1 over, I move down, 1.004. And when I put that into the calculator, I get 18.699755. Okay, now to get P on its own, we're going to divide both sides by what we have. So a quicker way to do that on the calculator is type in 1500, divide by, and then use the answer button. So that's ANS. On Casio, it's quite an obvious button. So I just put the answer, it's 80.21. If you're using Sharp, I don't have my Sharp in front of me, but you have to, I think, press the green button and it's over the equals. Just play around with it, see can you find it. It says ANS as well. So I put into my calculator 1500 divided by ANS, so that big long answer, save me typing it again. You can of course type it in again, I'm just super lazy with it. And when you do that, you're going to get 80/21. Remember, we are working in money here, so we are always going to round to 2 decimal places. So we had said 1,500 divided by 18 months, you'd need to save about €83.30. So we're actually saving €3, over €3 less than what we would if there were no interest. So this is a perk of saving when we're saving in a bank rather than putting in your piggy bank at home, because you will get that little bit, and every little bit helps. So one really important type of saving that most people will do in some shape or form in their life is a pension. So a pension is a very specific type of saving where you're saving for your retirement. So what you do is you place a portion of your earnings, and often in the private sector this is matched by your employer, and it goes into a special account and you can't touch it until you retire, and you get tax breaks on this. Often the interest rates are very good, and so on. So basically, when you get to retirement, your fund will then pay you a periodic payment to replace your wage you're no longer getting. So the idea is, if you save a little bit of your wages as you work, when you get older and you can't work, you'll still have a payment coming in. So pensions work in two ways. The first way is saving for your pension, which is just like the last two examples. We just want to save. We set up our geometric series and we work towards the future, having that big bucket of money to have when we retire. So then the second way that we can be asked pensions, and this is often why students aren't fans of pensions, is we could be asked about the payments that are made after you've retired. Now, the reason that that is slightly different is because, think about it, you have a big bucket of money and it's going to pay out money basically in the future. So the bucket of money is at the start. So we're going to see what kind of impact we have. But it doesn't matter, because in both ways we're still going to be using the same method, and that is the idea of setting up a geometric series and finding the sum of the geometric series. So let's look at a scenario. Imagine that you want a pension that pays you at 1,000 every month for a year. How much would you need in your pension fund to begin with? So, would you need 12,000? Let's have a think. So I want €1,000 every month for a year. So you'd say, oh, well, 12,000. But actually, the thing is, if we start with our bucket of money here, right? And I love drawing out my bucket of money so I know where I'm working. So there's my bucket of money, and I don't know how much is in that. I'm going to put a big question mark, because that's really what we want to figure out. Like, I don't know how much is in there. If I had 12,000, I'm going to have too much, because I want 1,000 now, and I then want 1,000 in a month, and then 1,000 again, and then ... and then 1,000. However, okay, remember interest. It's all about interest. And what interest does in this case, because we're working backwards, and that's important, right? We're working backwards. Here is the present. These are the future. So we're working backwards. So we're going to use the present value formula. And that is f divided by 1 plus I over t. So think about it this way. I take 1,000 now. That's fine. That's just come out. But this €1,000, well, this had a whole month to get interest. So I wouldn't have needed the whole 1,000 to pay it out. I can instead divide that by 1 plus I. The third payment then would be divided by 1 plus I, but it had 2 months, and so on. And then this last piece will be 1 plus I, and we would have that for the 11 months. So think about it in terms of the calendar. If I made a payment at the start of December, that has been sitting in the account from the previous January. So it's had 11 months to accrue interest. So even though there's only 1,000 left in the account at the start of December, there was probably less in terms of that payment at the start of January. So to understand where that bucket of money is makes our lives much easier, because if we're moving forward, so if I move this way and my bucket of money is here in the future, that's my future value. Okay, I want to understand what I have in the future. If I have a bucket of money and I'm taking out of it, right? So here's all my payments. Okay, so there's my payments. Here, my payments, I need to work backwards. So I'm not working forwards, I'm working backwards. So because I'm working backwards, I'm using my present value formula. So that's, again, they're both in the log tables and we've worked with them. F divided by 1 plus I to the power of t. And we still do the same thing because it is geometric. So we're multiplying, finding our OR, and so on. So there's our formula we're focusing on. It's that present value formula. So example 3, what amount of money is needed to provide a pension of 25,000 a year for 20 years, assuming an AER of 4%? So here's my bucket of money. I know that I make payments, so here is my payment piece. So I make a 25,000 payment. The next year I make a 25,000 payment, ... and then I make a 25,000 payment here. So that is, no, and I'll put one here as well, 25,000. So this is like the start of year 1. This is the start of year 2. This is the start of year 19. And this is the start of year 20. And that's my payment. But remember, all of these need to add together to give me the amount of money I need. But it's not as simple as that because of interest. And remember, because we're working backwards, there's our bucket of money. We're working backwards. We're using the present value formula, which is F divided by 1 plus I to the power of t. So my AER in this case is 4%, which is 0.04. So I'm going to, now year 1, like you've just set up your account and you're paid 25,000 straight out of it. So that comes out, there's no delay there. It's happening at the start. Okay, like if you need money, you need it straight away. So it has to come out straight away. So these are nearly attached. I've probably drawn that badly in that case. So like this comes out like of the bucket of money straight away. Like there's no time for interest. Year 2 is going to have had a year. So remember, it's at the start of year 2. So it's had a year to accrue interest. So 1.04. Year 19 has had effectively 18 years. Get rid of, I put those pluses in a funny place. So it's had 18 years, and then the final one has had 19 years. So just watch that. Now, we still have 20 payments. So A is equal to 25,000. I'm going to do N next, so it's still 20 payments. Don't worry about the fact it only goes up to power of 19. It's how many payments are there, because we're adding together. So one of the payments doesn't have 1.04. But how do we jump from one to the other? How do we get our OR? So actually this isn't a jump, this is a few jumps. So this jumps to there, ... and it jumps back. So just like before, you'll notice that I have a number and then suddenly it has a denominator. So it's like it's being divided, but we don't use division. Instead, we use fractions. So again, it is 1 over 1.04, which you'll notice is pretty much the same as the last questions. So even though our series here looks different because they're fractions, we do have the same kind of OR happening, which is 1 over 1 plus I, that interest rate. 1.04. So now let's use our SN formula, the sum of a geometric series, to figure out how much money we need. So we're going to do S20 is equal to A, which is 25,000, times 1 minus, again, OR is a fraction, 1.04 to the power of 20, all over 1 minus 1 over 1.04, and we stick that straight into the calculator to get an answer. When you put that into the calculator, we get 353,384.49. Now, if you wanted 25,000 for 20 years, that would mean you need 500,000. Like, we only need 353. So what you're going to start seeing is over very long periods of time, the interest makes a bigger difference. So although you'd say, well, look, over 18 months it mightn't affect it, but look at the difference here. So basically that interest has allowed us to save nearly 150,000 that we didn't need. Well, it means we didn't have to save 150,000. So in order to have 500,000, we only needed to save 353,000.